Okay, let's get started with the actual review now. What are we doing?
What I see is that most of what people are asking about the quiz review. But I think that before we go quiz review, let's kind of talk about GUIs a little bit.
And here you go. That's all you.
Awesome. So we're gonna just pull up Jesse's slides. Yeah, we can just turn off the lights closer. Yeah. Logan will handle that, and then we're gonna.
There we go.
Okay.
What are you looking for now?
I'm switching into your browser so that I can just pull up the actual GUI slides.
Oh, okay, yeah.
Because if I have you guys like choose a topic, I'm not magically like able to tell what topic you guys want. So like I don't have slides prepared. So are we streaming and ready?
Yeah.
Awesome.
It's been going. It's just been UB Hacking Talk for a while.
Yeah, that's fine. So, hi guys.
Also,
anyone on the stream?
Actors. We've learned it once, and do you understand them?
Yes. So I reread over Jesse's slides, and for reference, Jesse's slides are much better than they were last year.
Yeah. So I now understand them, and Jacob now understands them, but not every TA understands them.
Yeah.
Right. So if you go to an office hour and there's a TA that doesn't understand them, go to a different TA's office hours, because actors were like the one thing last year that we just did not get it on.
They were barely covered. They weren't a heavy point on how the course was run. And then also, like, Jesse last semester had lecture questions that were free when he didn't know how he could possibly grade them on AutoGrader. But now at this point, because he's had a semester to figure it out, you guys aren't getting any free lecture questions. And so, like, you guys are also required to essentially figure out kind of how actors work, and so like it's also structured much more better, like easier to understand.
Much more better. We're good at English. Okay.
This is why we're CS majors.
Let's go.
GUIs. How do you pronounce GUIs? GUI. Nothing weird like what Steven will ever say. Awesome. So lecture question. You guys have a lecture question? I'm kidding. No, you don't. So basically, here's the big thing on this first slide. It says Scala FX, and it says an interface for Java FX. A big thing with GUIs. When you import stuff for GUIs, you need to keep track of what you're importing from Java FX and what you're importing from Scala FX. Because a few problems that I saw with some people who had this lecture question that was here, what happened was they had an event in which they had the event listener like imported from Java FX, but then the actual mouse event itself was imported from Scala FX, which doesn't necessarily throw an error in IntelliJ until you run it, and then you run it and you have no clue what the error is because it's just spitting back a bunch of garbage. But essentially, you need to keep track on what you're importing from which. A lot of that is double-checking Jesse's code that he's written and showed you in lecture slides and other code that he's given you, and making sure that like types line up. Like it's the same idea as even though you may import one thing, like if you have two things and they are using each other directly, like if you have an event that's like if you have an action handler that's extending an event handle, and that inside of that event handle is a mouse event, that event handle and mouse event should both be from the same package. If they're not, it may cause problems. So double check your imports. If something is going wrong and you don't know why, check your imports, because that may be what it is. So yeah, this is a GUI. That's pretty. Let's get into code so I can just kind of explain code. Let's start with here. So here's this kind of the starting type thing is like, here's where you look at some of the imports, and essentially you have an object and you can name that object whatever you want to do, and it's extending a JFX app. That JFX app is specifically from the ScalaFX.application package, and it knows there that it needs to also be using scene, and it needs to be using primary stage, because those are all things that need to be the same. If you are importing one of these from JavaFX and the other two from ScalaFX, you're going to raise an error. And so like that's where you need to start like double checking everything. And so this is also where you kind of see a trait in action. And so if you guys remember when we were talking about inheritance and traits and that type of deal, this is a trait. JFX app has all of the stuff that it needs to be a GUI, and essentially by extending that, you give sample GUI the ability to be a GUI. And so at that point, then what you're going to be doing is you're going to set up the primary stage, this is just documentation stuff. If you're confused about how specifically, like what new primary stage does, my best recommendation is to go and Google Scala effects documentation, find the official documentation, then find the method primary stage, because they're going to have all of that documented on specifically what parameters it takes, what it returns, how it works, like what other special features you may have access to. And like that's the thing that I use for a lot of different things that Scala has, because like for lists and arrays alone, Scala has like 30,000 different types. Like you have list buffers, array buffers, mutable lists, immutable lists, mutable arrays, immutable arrays, and all of the under the sun, like all lists and arrays and stuff. And each of them kind of have different roles and do different things. And you can look up all of this stuff from the Scala documentation and whatever library documentation you're using. So that's another recommendation that I keep throwing in every review session. Check the documentation. It's going to save your butt. So yeah, inside of primary stage, you need to give it a title. You need to tell it what its scene is. And that scene is then going to hold some stuff. That scene is essentially inside there where you're going to clue in the GUI to what it needs to display. Because if you just run it like this, that list is empty, and so you get that empty screen that's on the left. So here's the imports. I talked about that. Awesome. So, text fields. So inside of the app, what we are creating is, if you see, we create a variable that we label as a text field. That text field is coming from a Scala effects package. So that text field then has all its own properties that you can see in the documentation. We're specifically giving it whatever the font we want to do. And we know that from the documentation, a text field is an empty box that you can type into. And then what we know is that input display, if we then look farther down, inside of scene, we then put vertical box. Vertical box specifically carries, a list that holds both input display and output display, which both of them are text fields. And so a lot of this is just nesting it all together. It looks pretty confusing at first glance, but essentially what we're doing is we're just taking, okay, here's an element that's a text field. We know that that element takes a text, and then you can type into it, and then you can do specific things that call that text. We're then nesting it inside of a list, which is how the documentation wants us to do it, so that those two are contained together. And then what we also know is that then that entire thing is going to be contained inside of the list of the content that is in the scene itself. So you can kind of think of the scene itself as the window, and the content equals list, and whatever that list contains. That content is anything that's inside of that window, and what it holds is whatever's inside. And so it's specifically holding a list that is both of the input and output displays. And so what we know that from that. What you can also see is that in output display, it takes a parameter where we designed editable to be false. That means that you can't click on the text box and type numbers in that, and that's another thing where you can find that out by just looking at the documentation on all the cool different random things you can do. I believe in Scala there's also things that are like a slider bar and that type of thing. All of those stuff you can find the documentation to, and what you would do new slider bar, if that's what it's called, and like any of those, and you choose the size, the amount, the increments that the slider bar does, like the range, and you could find all of the things that you could possibly need for a GUI. So that's what Jesse's reminding us about, is that Scala effects. We need to use all of the same type of thing from the package. You'll see when there's specific things that need to be Java effects. Specifically, Java effects stuff is going to be in the controller, it is not going to be in the view itself because the view is being run in Scala code, which means the view needs to be using Scala effects.
Time. Does everyone understand controller view model?
Model view controller.
Model view controller. Does everyone understand that?
Okay, so I'll kind of...
Let's go over that before we go back.
So let's hop out.
I have Photoshoppy stuff on here now, so we can actually use that.
I was just going to pull up his MVC.
Oh, yeah, that works too. You start talking. I have to fix this really quickly.
So MVC, essentially how MVC works is it stands for Model View Controller. So let's look at a standard video game system to kind of explain what MVC is. So if you think of an Xbox as a total system, and we're looking at it as MVC, the view is specifically the TV that you have your Xbox connected into. The controller is the actual Xbox controller, and the model is the Xbox system itself with your game inside of it. And so your model is essentially the machine and the code that runs everything. What it does is it reads your code, it runs it, and reacts how it should based on whatever the controller types. So if you hit the A button, then what happens is the Xbox gets the response, okay, the A button was hit, and then it knows, okay, if the A button is hit, if I'm in this game, then it needs to do this thing. If this is hit, then that is done. It handles all of that in the controller itself, which is why if you guys came to my office hours for calculator, if I saw you had too much code kind of nested in your controller for calculator, I tried to urge you to put it into your model as just better code practice. Because think about it this way, if you put actual code into your controller, what happens if you disconnect your controller? It won't work. And so you want to be able to swap out that, let's say for calculator, you wrote your calculator with no control flow. Let's say you didn't want it to be the specific GUI we were using anymore. Let's say you wanted to use a whole different GUI that you restructured and built yourself that was actually meant to be a web app that you were opening up in Chrome. But like if you had code in your controller, then what would happen is you'd then have to pull that code out bit by bit or replicate that code inside of your other new controller for your new GUI, and that would just be a whole pain, and it wouldn't, it makes it much easier to swap out stuff if you have all of your model code inside of your model itself. And so controller's pure job is to take inputs from the user and send those inputs to the model. The model handles it, does whatever it needs to, and the model says, okay, this is what I need to display now. And then what happens is when your view goes, I'm ready to display something, your model goes, here's what to display. So if you are in a video game, what it tells you is that when the screen goes, I'm ready to display, your Xbox goes, here's where what color each pixel is on the monitor going to be. It doesn't know anything of where, it's not going to go, oh, there's going to be a character here or a character here. Your view is just going to know, okay, this pixel 00 is going to be 255, 255, 255. This pixel over here is going to be 125, 250, 40. It doesn't know specifically anything about where characters are in the view. It just knows this pixel here is this color, this pixel here is this color. And so everything is stored as numbers. And that's kind of how MVC gets put together of the view and the controller don't communicate, but the controller communicates to the model, and then the model just goes, okay, view, this is what you're showing. It's like in calculator, you had the method display number, and all it did is it returned a double. It didn't need to know, okay, the view doesn't need to know, oh, you hit a plus. The view doesn't need to know, oh, I'm going to do some math here now that I'm requesting for whatever I should be showing. It doesn't do any of that. It just goes, okay, I want a double because I want to display a double in that actual little window on the calculator. Does that start to make sense about what MVC kind of is? What MVC is essentially not just an idea of like what you're coding. It's a concept on how to code, how to set up your code to be a good program, to be a good software developer, so that it is modular so you can swap around if you need to. Awesome. Let's jump back into GUIs.
Oh, my touchpad is weird today, so just hit it if it decides not to
Just smack it a little bit.
Honestly,
Percussive maintenance.
literally that if it decides not to work.
Okay. So, that's called percussive maintenance for those of you who have ever worked IT. I have.
Therapy, but yeah.
It's fun. I love hitting computers. It's called computer abuse. Okay, so GUIs. Essentially, we talked about text fields, and so what do you think that input text field is going to be directly related to in the idea of MVC? The input text field, it's going to be a window where you can type in a number. What do you think that, how that, even though it's in, like it's going to be shown to you, how do you think that's going to play a role in the MVC? Anyone? Controller? A controller. So yeah, essentially what it is that's going to be part of the controller. That's going to be you type a number in, you hit enter, and then what the controller is going to go, oh, this text field is holding 37.5. Then it sends that number into the model. The model is going to figure out what, if it needs to convert from Celsius to Fahrenheit or Fahrenheit to Celsius. And it's essentially going to go, okay, I need to convert to this. So then it's going to go do all the math that it needs to do. And then it's going to go, okay, view, this is the number that's outputting. And view is going to go, where's the number? And then model is going to go here. And then the view is going to show that number. And so that's where if you put 27 in, that essentially what would happen is if we had it all set up with this button, that we'll now talk about the button, but essentially, like we don't have the button doing anything just yet, but essentially the button would then trigger the action of saying, okay, whatever's in the input, the controller, we're going to feed that to the model, and then what's going to happen is, okay, let's actually, I'm going to escape this. I'm going to put this like this, and then I can go like that. I can go here. I'm doing fancy, so I can do alt tabs between these. Awesome, yeah, so essentially what's going to happen is the controller is going to go, here's the number, it's going to feed it to the model is going to send it to the view. And once the view has it, then the user will be able to see, okay, after that conversion, the new temperature is whatever it needs to be. And so let's kind of talk about buttons. Buttons are weird. Buttons are very helpful. They're confusing to understand on how action event listeners work with them. So, when you create a button, you can use the Scala FX button, and you're feeding it whatever size you want that button to be. You're feeding it whatever text style that you want it to be. You're feeding it whatever you want to be displayed on the button. So that can be F to C. You could also set it up that essentially the string that is shown on the button could be changing. So you could have a button where what would happen is, like for clicker, you may have a button that shows, okay, shovels, you have specifically 3 shovels. That button may show shovels : 3, and then when you hit it, it may go shovels : 4. That string right there in the text, you can update that, and that will update what the button shows. Because the button is only registered from specifically that variable name that is button. And so you can change whatever the text is in it. So what happens is when you create a button, you need to essentially, okay, let's go on to the next slide. You need to set up a specific listener. Your code doesn't naturally just know if a button has been pressed until you set up a listener. So you need to have a line of code set up that essentially means, okay, this line of code is essentially going to be listening in. If this button gets pressed, that line of code gets activated. And so what will happen is that button listener is an action event. That's like when you looked at actions.scala in your calculator class. You had an event action that was called new number action. It took calculator and it took an integer from 0 to 9. That specifically would have been in the aspect of if you had a button and its text was 1, then what you would know is that on action it would be new number action. It would take the parameter of whatever calculator was created, and it would be comma 1 because that was the 1 button. And so what happens is when that action gets called, what happens is specifically when you click the button, that's like calling the method handle. That was where, like, when you guys were testing, some people got a little confused about that. When you tested, you had to do not just new button listener with the parameters, but you also had to do dot handle of null. Because specifically, you needed to tell it that that button actually got pressed in that instance. And so by telling it that button got pressed, you're able to keep track of then, okay, handle got pressed. And so right now, this is where I would call this a little bit bad code. Of Jesse has the math being done right now inside of this controller. I would have it call a separate method that's in the model itself that essentially just takes in whatever the current input number is, and then what happens is it outputs it to the display. He doesn't have it set up that way. That's fine. Essentially what he's doing is he's saying, okay, rather than putting that code in the model because it's only 3 lines of code, we're just going to do it inside of the controller because it's small enough code, and this is just an example for a lecture question, essentially, that what we're just going to do is say, okay, the Fahrenheit is whatever that text, that input display is currently holding. Excuse me. If you only know that you have input display, you don't necessarily know that dot text, then dot value, then dot to double exists. And so you don't know if you have access to that or not. That's where you can look at the documentation to figure out what you have access to. That's where also IntelliJ may actually be slightly helpful for once, where you can do dot, and before you start typing text, IntelliJ will show you everything you have access to in a drop bar. And so you will see you'll have access to text and a bunch of other things that I would hop into Logan's IntelliJ to try to show, but like it's simple enough that you can just hit dot, and whatever that drop bar is whatever you have access to for that variable. And so you don't need to memorize anything, but you can just say, okay, well, if it's input display, well, I have an option for text. Well, if I'm trying to pull the text, that makes sense. And then if you hit dot again, then you can see, okay, well, I can pull the value of that text, which would make sense if that's what the text is currently holding. And then you can do dot to double, because if you typed a number in, it may be in a string, but you don't want it in a string because you need to do math with it. And so you can do dot to double. Now, what does dot to double also allow for you to do to make sure of what happens? Think about it. So we have a calculator that essentially takes Fahrenheit and converts it to Celsius. What does the to double do? Yeah. What happens if you have an invalid argument? It throws an error. And so this would be a situation where essentially you also have your converter set up in a way that if someone took that text input and they just typed some letters into there, you'd crash it because that's not how it's supposed to react, and so it wouldn't suddenly try to do math. That's where in this case, if you wanted to have it foolproof so that the app didn't crash every time, you could throw in something that basically says, if you cannot convert to double, if it is of type string and it is not a double that is inside of a string, then essentially what you can do is you can just throw an error and say, you can put a print message on the screen that says, please put in a number, not a string or that type of thing. Yeah?
What if you compare the ASCII values of like number 0 to 9? If you compare to that, or if it's not, if we go back to this and throw out an error,
So I believe Scala does have a specific function to check to see if you can convert a string to a double, if it's like able to be done in that specific runtime. But yes, you could essentially parse the string character by character, checking to see that only one decimal point exists in the entire string, like the entire character array, and then also checking that every character is between the ASCII value for 0 and the ASCII value for 9. Yes, you could do that. I believe Scala already has a function built in that you can check to see if a string is a number. And so, essentially, how are we feeling about this so far? Are we understanding this a little bit more, understanding kind of what slowly pieces together with the GUI, how things kind of get passed? Now, here's a question. How often is, like if we store something inside of class button listener, how, like if we pass in input text field and output text field, how often is that going to stay there? Like, do we, the next time that we call handle, is it going to hold that old input display or an output text field, or is it going to hold the same one that we just, when we click the button? Yeah, so essentially I heard a few people say it. What's going to happen is every time that button is clicked, whatever was currently in the position of input display and output display is going to get passed in, which means if you try to keep a value from the last time you passed it, and it's only in, like, passed in as a parameter to class button listener, it's not going to stay for the next time you click a button. So you need to keep it inside of something that isn't changing. So, like, if you have this specific GUI that is over here, you could have a state variable that keeps a running track of all the temperatures that you've done, and then you can also pass that in to the button listener so that it can keep a running total of the previous ones as well, if that's what you want to do. So you could have it, rather than displaying a single number, you could have it essentially take, whenever you hit the button, it just appends a list, and then it displays the list. So if you converted 79 to Celsius and then 42, it would show all of those answers, comma, and then the next one, then the next one. You would have to keep track of that outside of the button listener itself, because the button listener is not going to keep track of it, and it's going to erase whatever values it has after it does its handle call. Does that make sense? Awesome. So, I think that covers a good amount. Okay, so let's talk a quick thing about event handlers and action events. So specifically, this is where like the imports really matter. That this is the only area where you're doing Java effects, where you're doing extends event handler action event. Those two need to specifically be from Java effects. Everything else you're doing is Scala effects, because if you try to do event handler or action event as a Scala effects package, if you're doing one of them or both of them, it's not going to work that way, because that's not how they have it set up in the libraries and dependencies. That's just how the imports are. That's just how the packages are set up. It'd be like that. So essentially, you just need to keep track of those import statements and make sure that you don't have any like type mismatches. Awesome. Anything you want to add about that?
If you're done with that, I'll go over the quiz.
Awesome. So Logan's going to go over the quiz and talk about that.
Yeah. It's what you're all here for. And I only know that because that's what I would be here for. Hi, everyone. How are we doing today? It's been a long day. Okay, so direct from Jesse, I have words that I'm not going to show here because I'm going to paraphrase them. That's okay. So on the quiz, you want to type paraphrase stuff, but like not exactly what he wrote here, but like you know what I mean.
Type while you talk.
Yeah.
Let's just hop into docs, and then I'll just, this is
just
lab
make a new
activity
one.
one, yeah.
Okay, so there's gonna be 3 questions, which follow the 3 weeks of the level, right? Okay. So there's gonna be, I'm gonna give you guys the topics, and then we'll go like in depth on each one, right? Okay. There's gonna be a question on inheritance and polymorphism. There's gonna be a question on states and state diagrams, and then there's gonna be a question for GUIs. Okay. So let's start with GUIs, and then we'll work our way back. So for GUIs, what Jesse's going to do is...
Wait, what was 2 and 3 quick?
Inheritance, polymorphism, states and state diagrams, GUIs. So what Jesse's going to do for GUIs, he's going to give you the code for a GUI, right? He's going to give you the code for a GUI and the GUI itself, right? So he'll draw like the GUI, like we saw similar in the Fahrenheit to Celsius conversion kind of deal, right? He's going to give you that and the code for it, and then he's going to give you a bunch of inputs that are put in, and he's going to ask you for what the value ends up being in the text field. So, for example, if he gives you a GUI, right, that has Fahrenheit to Celsius, right? Let's say, just how we had in the example. If he'll put, if I put in 72 in Fahrenheit, what's it going to give out? If I put in 32 in Fahrenheit, what's it going to give out? That kind of stuff. Super simple. I doubt it's going to be Fahrenheit and Celsius.
That's too easy.
Yeah, that's the example we gave for lecture. So it's going to be something, and you're going to need to just figure out what it does and follow the code, right? But here's my like one little hint that I don't know, but I'm just going to say anyway, right? So if he gives you something that says Fahrenheit to Celsius, right? If you in your head know the conversion from Fahrenheit to Celsius, don't assume that Jesse actually put that conversion in there. Because he might have just said add 27, and that's his conversion from Fahrenheit to Celsius. Right? Don't assume anything. Go through every single step of the code and make sure you're correct. Like if the button says like add 2, make sure it's not adding 4. Like check with the code. Okay? Don't just assume from what it looks like it's going to do. Let's go back on. So for the states and the state diagram, he's going to give you, so we're going to skip state and state diagram for a second, we're going to come back. So he's going to give you a couple of, for inheritance and polymorphism, okay? He's going to give you a couple concrete classes, so more than 2, that they all extend one single abstract class. So if you'll remember the ball example we did, so that ball example, that ball is the abstract class, and the concrete classes for like football, baseball, basketball, right? And he's gonna, in the concrete classes, it's gonna override some methods while using some other methods for it. So, for example, do you mind pulling up the IntelliJ? Really cool. Yeah. So so like here, I'm gonna use this now. In here, we overrode all of these methods here, okay? So he's gonna have classes that don't override every single method, that also have their own methods within them. So let's say in like the Windows class that we had right there, if it did something Windows specific, that method would only exist in the Windows class, it wouldn't exist in every other class. So he's going to give you the code that creates a data structure of the base type and adds a few objects of each concrete type. Okay? And you're going to do something with the data structure, and you're just going to make sure you know what's called in each case. What will happen is he's going to give you a chunk of code, right, that's going to make a couple of each of the concrete objects, and he just wants, and it'll transition between them at any given moment. He just wants to make sure that that you reading through the code, you understand when things transition and what they do when they do transition. Right, everyone got that? Alright, and then states and state diagrams. So it's probably going to be, he didn't give us much on this. It's probably going to be, he's going to give you code that uses states. And then he's going to have you draw a state diagram for that code. Right, so tonight make sure you remember how to draw a state diagram. That's super important. I saw a state diagram on the quiz when I was the one who graded 98% of the state diagrams. So I can tell you a lot about them now. I saw a state diagram on the quiz that said calculator, and then it had 3 little bubbles coming from it. One said variables, one said lists, and one said methods. That's not a state diagram. Please, for the love of God, don't draw that. Right, okay? So make sure you know what a state diagram, make sure you know how to show it. Make sure you write your transitions in the state diagram, right? So on calculator, if you went from, I don't know, if you went from like number pressing state to an operator state, make sure you show what your transitions are between, right? Like make sure you see what function you call that switches the state. Like if you don't show me that they switch states, then I can't help you on that.
Like in calculator, if you went from an equals state to a number state, what happens?
Yeah, like what method do you call it? Do you call a clear method? Or do you call a number method or something like that? Just tell us what it is. If you say, and be somewhat descriptive, like don't say method X. Like, what does method X do? Either explain that to me or just put a descriptive method name, like def clear and not def X.
This is another situation where the more you write and the more detailed you are about your procedure, the easier it is for us to give you points. If you're vague, we can't necessarily give you points.
Also, last thing on state diagrams, there's a little bit more to the state and state diagram thing, but while I'm talking about state diagrams, please bring a piece of paper to the exam, like just a piece of printer paper, blank, like don't cheat or anything, but like there were so many state diagrams I saw that took up half the page in the actual thing, went on into other questions and had lines going everywhere, and it took me 20 minutes to decode some of these, right? So keep your state diagram as neat as humanly possible. Try not to overlap arrows. I know it has to happen sometimes.
Bring a ruler if you can. Or use the back of a calculator. We all know how to do that, where you just use the back of the calculator to draw a straight edge. Do that so your lines are nice and straight, so there's not any possibility of them crossing over and then you not knowing where what's going.
Right, so I had somebody who literally had, I think it was 12 lines overlapping, and it was really difficult for me to tell where your states were transitioning and where they were transitioning to and how they were transitioning, right? You want to make it as clear as possible for the person grading, because once I got to like the 132nd, like they all start to go together, right? If you can make yours clear, if you can make it easy for me to look at and easy for me to grade, my life will be better, your grades will be better, right? Make this simpler for everyone.
Here's a great example. If you have 5 states, essentially draw 5 points. You can label them. If you have 5 states, how are you going to show all of the transitions between those states? You just draw nice straight lines. And what happens is by drawing nice straight lines, I just drew 2 lines in the same direction, but if you draw nice straight lines, then what happens is all of this, they're nice straight lines, you can see exactly where they are, they're all evenly spaced out, and if you label them as, like, put actual helpful things, but like X, Y, Z, A, B, like, then you know, okay, this is that state, that's that state, that's that state, and then you can write on each of these lines, oh, A going to B, and you can do A going to X, that's X right there, and I'm not illiterate, it calls, like, this method clear. And, like, you can write on those lines on where those transitions are by those lines to make it easy to show, okay, this is where it goes from here to here, and this is what happens. When it goes from here to here, this is what happens. And you can draw those nice and easy like that.
Here's another one. If you've got a more complicated state diagram, right? So if you've got 5 different states and they're going to 5 different other states, so you got X, Y, Z, A, B, which is also going to like core variable naming here, right? Please don't do this thing, right, where you draw it to every single one. Do me a huge favor, right? Write these here, and just make little lines that say X, Y, Z, A, B. Just don't draw across the paper. Make it easy for me to read, right? I know this means this transitions to X, to Y, to Z, to A, to B. And then just make a little arrow here and like a little nice blurb that says to X. So like here, I'll write 2X, and then this is going to be like def X, right? That makes it so much more simpler for us to grade. And I know it sounds like we're complaining about grading, but we're really not, because these things are really difficult to look at. And if you make it really difficult for us, we're not going to grade you guys well. Because some of these were really bad. I don't know if you saw them, but
I saw a few pictures you sent in the Slack, yeah.
They were not good. So the rest of that state thing, because there's more, he's then going to give you a name, right? He's going to give a sample main and then ask what happens. So, for example, again, with the abstract class kind of thing.
Where is that under?
It's GUIs.
GUIs, okay.
Some sorry, states. So, for example, he'll give you something starting in a football, and then it'll transition to a baseball, and then it'll transition to a soccer ball. It'll move states, and you guys just have to make sure you know what the code reads, right? So, a large majority of this exam, right? Looking at it here, make sure you know how to read the code for each of these things, right? I know that sounds stupid and like a given, but if you know how to read code, you should be able to do this fine, right? If you can follow the code that you've written already, because you've all done calculator, you've all done at least states and inheritance and polymorphism. Like, you guys should be experts in that now, and if you're not, you should be really, really good at it, right? So that should be easy. The GUI, just go online, go back to the slides and make sure you know how to follow every single GUI thing. Go to the calculator GUI, right? Because Jesse gave you guys a calculator GUI.
Throw print statements in the calculator GUI, and just like, it could be print, okay, button got pressed, or print, like, GUI started, or print GUI requested, like, display number, and you can throw those print statements in and then watch your terminal as you're pressing buttons and see what print statements get printed, so you can like watch, okay, this function in the GUI got called here, this function in the GUI got called here, it was doing this thing, and you can keep track of all of that. Another thing to say with the main method on states, there are some people who are able to just look at code and essentially figure out what exactly it does. You don't need to be like that. You don't need to be able to just look at code and magically know what it does. But what you should be able to do is look at the code and go line by line and keep track of everything. Pretend like you're a debugger and go line by line and update the states of everything as you go line by line. Because if you start trying to infer, if you start trying, oh, well, it seems that it's doing this pattern, or I think it's doing this pattern, and you get that wrong, then what's going to happen is you may get the entire question wrong if it's like level 1 quiz where there were questions where it was you had to just keep track of a number, and if that number was wrong, it was wrong, and that was the entire problem. That's how it was graded for that. And so essentially, like, go line by line. Don't try to look at the code and just infer what it does. Just go line by line. It's going to take a little bit longer, but you have 50 minutes, so spend that time rather than leaving early so that you know that you understood what it was doing, and you know you tried to limit the possibility for making stupid mistakes like, oh, I forgot that there was this transition from this to this, and that completely screwed me up. Like, I don't want to hear, like, I don't want to see that when we're grading, that, like, you were following it 90% through, but then you started inferring, and you were like, oh, well, then it's going to do this thing. But in reality, it didn't, or it did something else, and you were 90% of the way there, but then in that last, like, 5 lines, you strayed away, and what happened is that's a 0 if that's how the question is graded, and I don't want to see that. I hate seeing that. And so, like, follow the code and go line by line. Yeah, Logan.
I'm done. That's all I got on the quiz.
Yeah. So, questions on the quiz. Okay, good. Okay, questions on the quiz material, states, actors, GUIs, shoot.
How do you know when you are supposed to use overrides? Like,
I got this one. You've talked a lot tonight. I
Yeah.
got this.
Yeah.
All right, so you use override when you're trying to override the method. I know that sounds really stupid, but so let's pull up code, right? So so in this example here, right? So we've got a bunch of overrides. So if right, so we use overrides when we have an abstract class, right? So the whole point of an abstract class is there's nothing in there. So this is a state class, which is a little different, but it'll work for this context, right? So we have a bunch of methods that we've created. So the best way to think about it is an abstract class is a template for every class that you're going to make that extends the abstract class, right? So when we make a PC, right, we're overriding all of these things. It's the template, and we're specifying what the general things are going to be, right? So we override it when we extend a class. You have to override. We extend an abstract class when you create a template, right? So if you go into like Microsoft Word or something and you choose like the resume template, it says like years of experience, and then it gives you a box, and you got to fill all the boxes in, right? So this is like filling all the boxes in. So we're going to override every single method that came with the class. But if, for say here, not there, if here I wanted to go, I don't know, turn on PC, right, which returns a unit, this you wouldn't have to override because you're just making it here, right? Does that answer your question?
yes.
Okay.
So once you get into stage, you don't have to state it.
Correct. So the things you're overriding, those are general to the template, right? So again, let's go back to this resume example. Like you open a template in Microsoft Word and you have a resume, right? So you go through and it's got like years of experience, education, and that's it, right? But you decide you want references at the bottom. You just add it to your document, but you don't add it to the template, right? So it's things specific to this situation.
It also means that if you are calling that document that you write, if you're calling that document you wrote and it was of type template, then template wouldn't know that you added on references, so you wouldn't be able to call references. But if you had the type as that document you just typed, or let's say the type PC, then what you would know is you have access to Cortana.
Yeah, so I renamed it Cortana because turn on PC is really kind of vague. So Cortana is only available on Windows computers, right? So if I was on Mac, I'd go def Siri, right? Okay, so it does something specific for this class that only is going to ever happen in this class.
What if Cortana in the state class, you override it in the PC class and not the limit, but in the Mac class you override it with nothing.
So think about it this way. You could do it that way. That's totally like valid, totally viable to do it that way. But if we go back to like our different classes, we have Linux, right? Linux doesn't have an assistant built in. So I only want it to be in Mac and PC. So you could create a state method, right, that just has like virtual assistant or something like that, and it'll call like Cortana or Siri or nothing for Linux. Or you could just only implement those things in the Windows and the Mac part, right? The other thinking about this is you have to write .cortana, right? So if you were to create a new object and write .cortana and it was a Mac, it flat out wouldn't work, which is kind of a testing kind of thing. It lets you make sure you're in a Windows thing. In like the Windows class, you have an object of the Windows class, otherwise it won't work.
If you developed an algorithm where you know at this line in the code, I am going to be in the PC state, so that you know you have a variable that is of type PC, then you can call that variable's .cortana. But if that variable is just of type state, then you won't know that you can call Cortana, and IntelliJ won't let you compile.
IntelliJ doesn't forget that Cortana is not in the abstract.
No. Correct. So, as I was saying like before, like the abstract class is a template. You can add stuff to the template. You just can't subtract stuff from the template.
Unless you now use it in the other classes, then you can take it out.
What?
Now you use it in the other classes, then you can take it out of the
Say that one more time.
Okay, say you have these classes, you have the state class. If there's any method you know using this class and you're going to say, so you change your mind to take, let's say, open browser out of these are the three classes. You're taking them out of it. That means you have to take it out of the state class as well.
Yeah, so if you only want it in one of your classes, then it can't be in the state class. Or if you only want it in two. If you don't want it in all of them, then it can't be in your state class. Because your state class, right, template example, your state class, your template must have years of experience and skills. Or years of experience and education, right? So it must have those two things. Then you can add whatever you want to the rest of it, but it must have those two things, so you can't delete them from it. If you want to just only have them in that class, then you edit the template to not have to have all of them.
Okay, so like I have a question where you have this not current process stuff. Like why did you use the variable instead of using the parameter of the parameter of computer user, which the user? Like, cause in most of the state examples, like we would get the parameter, and then we would use the parameter for whatever we're doing. So I'm just wondering why we didn't do it in this, or when do we do it then?
So, like, where current processes could be inside of user as a whole, the reason why current processes is inside of just, it's initialized at 0 every time, is the point of this is saying, like, essentially, computer user is just the user itself. The user isn't holding the processes, it's whatever computer we're in, and based on if we shut down the computer or we switch from PC to Linux, if I take Logan's computer and I switch in, I don't think he has Linux on his computer as well,
VM.
but if I,
I got a VM.
if I open up his VM that has Linux in it, is that Linux going to magically have all of the same processes that his Windows had in it just because I was switching into it? So that's why we're having this inside of PC, because it's starting at 0 every single time, and we only want it to be inside of each operating system because the operating systems aren't going to carry them from user to, like,
it's not going to carry the processes from operating system to operating system, but it will carry the state from user to user.
Yeah.
Between your user. That make sense?
Yeah.
Okay. Any other questions on this while we're here?
I'm just curious. You just explained it. How about super? What's the difference between super and base?
You want to take this one?
Yeah, so
I never used super, so.
So essentially, like right now in this case, because we did say that super.name equals PC, super.name is var, and so essentially what we're saying is that we're updating the name when the PC is established, and essentially inside of that state class, we have a variable called name. If Logan wants to,
Yeah, I was trying to side by side.
you can just right click it and then do split horizontally.
No,
Or
vertically.
vertically, that also works.
Yeah.
So that essentially we know we have a variable called name, and that starts as OS. What super does is like, you don't necessarily need to use this and super inside of Scala, because Scala will just infer. Like if you know that we just take this and we just go, okay, delete that, it still knows its name, because it just infers, okay, name is inside of the class that we extended. It just knows that, but as a good code practice, and also what makes it easier for us to show you guys where things are stored, like name as a variable is not currently stored inside of PC. It is extended from the state itself. And so by saying super, we're just kind of trying to be clear, that variable is not stored inside of this class, but that class has access to it in its own copy of it, which is specifically inside of the abstract class it extends.
So super refers to the abstract class.
Yes, it refers to the thing that, if we are extending something, super refers to the variables inside of the thing above us. Like if you drew it as a diagram, you said, okay, we have state, and then we have PC, Mac, Linux, all extending that state. Super is the thing going up the tree.
So, I've got like one little thing that might like help you understand this a little bit better, right?
No, I understand that part.
No,
Okay.
just in general, right? Okay, so if I make another class, right, here,
new Scala class, right? And I call this like, I don't know, Lenovo. So like we're getting more specific now, right? Okay. So, right. So I'm going to go here, extends, what is it, PC, right? Which takes a bunch of variables that I'm not going to give it right now. Right, so basically, if in this class called Lenovo, which extends PC, right, okay, if I did super.x, it would change this value here, right? And then, okay, does that make sense? Okay, so it wouldn't change if I also had, if I had an integer named x in state and an integer named x in PC, it would change the one in PC, not the one in state. It goes directly to the one above it.
And so you'd have to use super.super.x to get to the one all the way up the line. And so that's where, like, sometimes as long as you keep your variable names separate, Scala will most likely correctly infer which one it needs to access. But if you start having things named the same, and you start having things overlapping in what they're named, you need to keep track of when you're using this, when you're using super, and when you're using super.super. And like keeping track of all of that. And so easiest way to not, if this doesn't make sense on when you're accessing what, just name your variable names separate things. Don't name 3 different variables the same exact thing.
Okay. Yeah. So now super refers to the name here. Now you have current process state as well, and PC extends state. So what do you have? This stuff current process super.
So current processes in this case right here is empty. And so what has to happen is we have to override it to actually give it a value. And so you could also most likely, I believe, also say super current processing. Yeah, it changed because specifically what that's saying is the super.current process, if you see here, hasn't been defined as anything. And so you're essentially reverting it to the one that hasn't been assigned. And so if it's just an empty variable, you're trying to access an empty variable that hasn't been declared yet, versus inside of PC itself, it's been declared. And so you can remove this, and Scala will accurately infer, okay, this means the current processes that's inside of what I'm currently in, and not some other one of the extending one. Awesome. Questions? Okay. Yeah, shoot.
I still don't understand why you can just add in the Cortana method without including it in either state or computer user. So even with a computer user, isn't the state variable?
So computer user, so yeah, basically what will happen is even though this is being created, the state variable called state is equal to new PC. If we try to do state.cortana, you see how it's not showing up at all and it's red? It's because it's of type state, and so we don't have access to it. But if we had a separate variable that we called var OS and we made it of type PC equals new PC of this, we would know that because it is of type PC, we can do os.cortana. And so even though we created that separate method, if the variable we have is of type state, we won't have access to that method because we don't know that it's necessarily there and everything.
So you would have to add that method to state.
If you wanted to have universal access to it. But if you had in your code, if we mathematically knew, so like here, if we said to PC, and then we called this.state.toPC, and we were in Mac, or let's do Linux actually. If we were doing like this.toPC, then we would know that we could do, okay, user.state equals new PC of user. What we would know is that essentially this is PC, but even if we still tried to do user.state.cortana, it doesn't like that because we can't use it in that state. But if we created a separate variable in here where we just said, okay, we created its own variable where essentially we just had, okay, OS, var OS in here, and that was new PC, and that was user. Then with that, we could do os.cortana. And so essentially, like, if the variable, that's where you need to keep track of types. This is where polymorphism comes in, and this is where probably a question is going to ask you guys on the level quiz, which is exactly that. Like, if you put a method into a class, and it isn't in the abstract class, if that method, if that variable, like we have computer user, is of type state, if you try to call that Cortana method, even if you know that it's PC, you can't call the Cortana method because it is type defined as state, and you only get access to the variables that are in state. Make sense? Yeah. Yeah, versus having if you had a type as PC. If you had a type as PC, then you would know that you could access Cortana because that variable would always be type PC. If that variable was not type PC and you had it labeled as type PC, what would happen is you would get an error that would be a type mismatch and your program would either fail to compile, or if it was somehow in runtime, then what would happen is it would fail in runtime. Yeah.
So then when you change states from PC to something else, would that new PC that you created, would that be destroyed?
Yeah, so essentially in here, if we had, in Linux, essentially if we created just this thing here, where essentially we could do like var os equals new PC, as soon as this method is gone, that OS is gone. Like, essentially, like, it'll act like that had never happened besides doing the method call, and after that method call is gone, after it reaches the end of this block that is the toPC method, all of Linux as a class would disappear, all of that OS that we created as a new PC would disappear, all remnants of us calling .cortana on that new variable would disappear.
What exactly is the difference between inheritance and polymorphism?
So inheritance is specifically much more like saying extends state. It is talking about the implementation of using extends. It's using all of those systems to basically get to have a bunch of different classes react differently through the same method calls. Polymorphism is saying, okay, you could have the same, you could have new PC, but if you had inside here in computer user, if we had new PC and then we had var state 2 and it was of type PC and it's new PC, that actually, even though they are both being created as new PC, they have two different things that they can do. Because specifically, state has access to Hello OS, state 2 has access to Hello OS because they both extend state. But because state is of type state, we don't have access to any of the methods that are in PC. And so if we can call state 2.cortana, but we can't call state.cortana. It's red because it's of that type state, and so because it's of that type state, we only have access to the methods that are of type state. That's polymorphism, where essentially they may be both being created by the same thing. It may be new PC taking this, but because of just your type definition, you have access to different things. Yes?
Can you remind me what this dot state dot open browser, and then again that this dot state dot means again?
Here?
Here, like what goes here.
We just set it up in here that essentially, like, it's a method that is inside of state. Open browser is not defined here, so that means it has to be overridden in all three, Mac, PC, and Linux. And essentially, inside of Linux, open browser is going to return the string Mozilla Firefox. Inside of PC, it's going to return Microsoft Internet Explorer. And in Mac, it is going to, we don't have it implemented, but essentially what it would do is it would say current processes plus equals 1, and then it would return Safari. And so essentially they all have the same, you could call, if it is of type state, you can do that variable dot open browser on all three of them because it is type state and they all have that same method. But what you know is that if you were in the state that was Mac, what would happen is when you call that method, it would return the string Safari. You would know that when you call that method, if you were in the state of PC, it would return Internet Explorer. You would know that if you were in the state of Linux, it would return Mozilla Firefox. And so you can call that same exact method, but based on what state you're in, it does something different. More questions?
So like what, I don't know if you answered this already, but like what's like a sample question that could be derived from this?
So specifically, I think a good sample question that could be derived from this is exactly like what we set up here, which is if you're on paper, you're not going to necessarily see red there. What may be asked would be, because we haven't actually seen the quiz hasn't been finished being written yet. So essentially, this is just me speculating.
We're really good at speculating now.
Yeah.
Really good at it.
We're pretty good. Like 65%. Maybe higher.
Definitely.
Maybe Logan's higher.
Definitely.
Okay. So essentially, a good sample question would be right here where they both are equal to new PC. One is of type state. One is of type PC. And essentially saying, okay, of these lines, what lines might cause it to not compile? Obviously, because we have IntelliJ open, the obvious line that is going to cause us to not compile is the one in red. But if Jesse just has them printed on paper, you're not going to necessarily be able to see it. So you may have to look at it and go, okay, if you had this state code, and then you also had the PC code, and we split it vertically one more time, and we move that over there, that there, and computer user, then if you have this code here, you would see, okay, Cortana is a method inside of PC, but that method is not in state at all. And so you would have to look at it, okay, state will only have access to Hello OS, it won't have access to Cortana, so the question answer would be, at line 8, the compile would fail. And so that would be probably a good example of what a question may be that asks specifically about polymorphism and would be testing to see, okay, looking at your PC method and your state method, like, and these lines, what line would fail? The answer would be line 8. More questions?
Okay, so you know how you said state here?
Yeah.
That's usually like the initial state, right? So now that you have state and state 2, which one's going to be the initial state there?
So how this was just added for me to kind of just explain like what this, okay, oops. So this was really just added right here for me to explain like a little bit of the polymorphism and what has access to what. Specifically, the initial state here is just PC, but it is of type state. We could not have state 2 that we had created here be an initial state because it is of type PC, which means you can't reassign state 2 to a Mac or a Linux because that would be a type mismatch. because that would be when you create a variable, you can't change what type that variable is. You can change what it points to, you can change what value is held in it, but you cannot change the type. So that would be like if you had a variable, let's say var I equals 0, and it's of type int, you cannot then say down the road I equals 0.0.
Or I equals
5.0.
quote 1. Right, it's going to yell at you with that red line and say I is an integer expecting a string. Especially if saying it does not conform to expected type integer, right? It's a strong Scala and Java derivatives are all strongly typed languages, which means you have to give it a type that your variable is, and it is going to hold you to that type.
Yeah. Scala does give you the nice leniency that you do not need to type define, but if you do not type define, it infers that because I wrote just 0, that type is int. You can say double, and what that will do is that'll take the 0 and actually basically say, okay, it's 0, but because it's type double, it's actually 0.0.
The only way that you can actually switch types is if you do I equals I dot to string.
Nope.
Doesn't even let you do that, man? Wow.
When you initialize a variable, it is stuck at that type. You need to create a new variable to have it change types, because once you create, that's what strong type means. That essentially, as a variable has been created as a specific type, it is stuck to that type. It will never change from that type. Awesome. Question? So you could do this. This would be really confusing. Okay. Actually, no, it does not let us do this. So, but I believe I can do this.
No.
Oh, wait, no, I just typed things wrong. No, I want to type int. And that.
Yeah, it's going to yell
Yeah.
those two things same die.
Yeah, it yells at us because they have two things the same. That's the closest that you could possibly get.
So if you wanted to reassign something, you'd have to do like var I string is a string that is equal to I dot to string.
Yeah.
That's the only way.
You have to define it as a complete new variable. And so IntelliJ does have it built in that, like, essentially if you, like, by doing var, you're redefining a variable. And so I was double checking to see if you redefine a variable and it happens to have the same name as a previous variable, does it allow both of them to stay because they're of two different types? And the answer is no, because it knows that it has no way to tell the difference between the two of them.
And honestly, if you're looking into you need it as a string and as an integer, don't ever do var I string. Just wherever you need that as a string, just do I dot to string.
Yeah.
Makes your code a lot easier and a lot cleaner.
Because think about it this way. Here's another big thing that I saw with calculator. This line right here. If you change I, does I string change?
No.
No. This line right here is going to, when it compiles, I string will immediately get assigned to the string that is 0. It will not magically change as I changes, which is also why Logan was saying, just do I.toString whenever you need it as a string, because if you don't, you would need to update iString every single time that you want iString to change, which if you're updating it every single time, that's the same as doing iString equals I.toString, and if you're already calling I.toString every single time you need to update, just call it when in the side of whatever function I.toString. You don't need to create it as a separate variable. So, yeah. Question?
Can't you still get that same functionality if you just define it instead?
What do you mean?
Instead of var, you use that and then have it return it.
Yes, you could have it be.
No, just literally replace place var, like create the single
Yes.
function.
That is the actual synonymous as also saying this.
But yes, but you would also have to do.
No, you don't, because I is a state variable.
No, it's not. I is just a double, just chilling in here.
Yes.
Oh, it wasn't
It's inside a class.
Well, it wasn't purple before.
Huh?
It was not purple before.
Yeah, it was. Yeah, it was. Logan, yeah, it was.
Wow, I'm just literally colorblind.
So you just replace var with that, and it just
Yes. So
that'll constantly update every time you call it. It's a single line function that just returns
Yeah.
I dot to string.
it's a one-liner. It's not actually a variable at that point. That's actually a method call when you call iString. Yeah.
Are we going to use any type? Any type?
Later, but not yet.
Later, yeah.
And it's any val, not
Yeah.
val.
There's any ref. No, there's any ref, and then there's any val.
But there's
And
not
then-
any type.
Yeah.
You know that for a fact. You're mostly going to use any val.
There's a type that is called any.
Any value is referring to
Yeah.
in and go.
There's also a.
Yeah. There's a few stuff. That's a down the road thing to worry about.
That's like a 2 weeks in advance thing.
Yeah.
Awesome.
Awesome.
You'll get confused, then you'll come here for help.
And then we'll talk.
Is
Yeah.
Darwin talking about Lambda?
Lambda?
Yeah, what is that?
So, like, who talked about Lambda?
The TA.
Which
Tilla.
Tilla? Oh, okay. So that's Python specific.
Yeah.
Python specific, Lambda is a way to have a function inside of a method. That's function passing. Function passing inside of Scala we'll talk about much later in the course, but is not using Lambda specific. Inside of Python, you can do Lambda x : and then type whatever method you want. It's the way of nesting a function inside of a call. And so a few people, what I saw essentially to try to circumvent using states for calculator, they tried to make method calls inside of a map so that essentially they could call the map with the key and get that function, but they weren't passing the function perfectly right, and rather than doing that, I just was like, hey, create a state and do exactly what you were doing with that, but with the state, and they were like, oh, that makes sense now. But essentially, yes, Lambda is a function, it's being able to pass a function as a parameter, and that is not something we are going to be doing just yet. And we won't be using the syntax of Lambda because Lambda is Python specific.
It'll be a fun week when we do that.
Yeah. Actually, I don't know if you have Lambda in this. And no. Lambda does not exist in that in Scala.
There
Awesome.
is something called epsilon. Is that possibly what you're referring to?
Yeah.
Okay, so epsilon.
Yeah, var epsilon. Okay, so that's
So
calculus.
epsilon's a different thing, and that's a really kind of simple thing that doesn't sound really simple. Basically, it's significant figures, right? So if you get 2.9999999, right, and you're supposed to get 3, but you know you're looking for something even close to 3, you could say if it's within epsilon range.
Yeah, so basically, like, the point of that is, like, I asked a few of you when, like, trying to explain epsilon, I was like, okay, if you have 2.999999999 and you have 3.0, are they the same number? And then you guys nodded your head. And then I went, well, actually, you nodded your head shaking it saying no. And then I said, well, actually they are, because what happens is essentially how doubles are stored in memory is confusing. They have a lot of bytes. There's a specific point, there's a significand, and there's a signed versus unsigned. That's stuff that you'll learn in systems programming in 220. I'm not going to go into it here. You guys are going to get a headache if I try to go into it. I don't fully understand it just yet. Essentially, how they are stored is they are not stored perfectly as the number they are, and they only have a max number of bits that can be stored there. So what happens is if you do multiplication or division, what might happen is there may be a very, very, very slight rounding error, which may cause you to be 0.0 repeated 5 or 1 or like some tiny, 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 tiny number off, but that's purely because of how the math works in your computer. It can't perfectly store everything. Like, essentially, think about it this way. The reason why, like, it's a primitive data type is it can be stored in a specific chunk of memory. That chunk of memory cannot be infinitely large, because is your RAM infinitely large when it's allocated? No. It has to be of a specific size, that if we have this variable of double that's I, when the program gets run, it's initialized as 0, but essentially that double of I can only hold so much space, specifically 64 bits of space, inside of your RAM, which means you can't put a number in there that is larger than 64 bits. You could create a new variable that then is type long, which would allow you to do 64 to 128 or something.
Like that, yeah.
But essentially, like, yeah, essentially you would need to create something else to hold it, to have it hold more space.
Any other questions? Now?
Sorry, I had to go to the lab.
All good.
I asked on the forum about the demo 2.
Yeah.
Oh.
You asked if you answered that question.
No. We haven't answered anything before except for like the first question that we did.
Okay,
We're really bad about going back to it and like actually answering questions. What specifically do you want about demo 2?
Okay, demo 2 requires a local host for communicating with the GUI. How can I set that up? Awesome question.
So, essentially, I believe for this lab that's this week, you are specifically connecting to a host that Jesse already provides, and he already provides that networking code.
Correct.
For demo 2, I believe it is similar. I believe for demo 2 that essentially you are still going to be connecting to Jesse's server like you are going to be doing in Lab Activity 5, and you're going to be receiving a JSON string from that, and from that point you are going to be interpreting that JSON string to figure out what you need to show.
I'm going to check really quickly.
Yeah.
100% sure.
Because I believe the only thing we're trying to test from demo 2 is your ability to display on a GUI, not also write a whole server to host. While he checks, I'll answer the next question.
Also related to Lambda Activity 5.
Yeah.
In the instructions it says you can hard code the parameters for equipment, like its ID, its name, and stuff like that.
Yeah.
And assume that it's going to be a list of 3 items always.
Yeah.
Looking at it, like accepting any amount of equipment,
Yeah.
would you do that as something with like within the play library, or is that where any val comes in?
So specifically, if you're parsing equipment and you know equipment is a
Yeah. If you know equipment is a list of items, then you could parse equipment as a list of strings where you know that each individual, like, or a list of like JS values where you know that it's mapping from a specific point. Essentially, you could figure out, like, if you had a map and you know that like inside of equipment has a map and that map is string to JS values, you know specifically when you're doing your code that, okay, I have shovel, excavator in mind, but what you know in Scala is that if you have a map of strings to something, you can do like that maps variable dot keys, if I remember correctly, and that gives you a list of keys. So what you would know is that for that list of keys, you would have, okay, if you iterated through that list of keys, okay, you would know, okay, for key and keys, that key is the string that you need to use to parse for in that JS value, and also you know that that string right there is what you would need to be showing on the button. So that essentially you could do, okay, for key and keys, okay, I'm going to create a new button, and its text is going to be that key, and then it's going to hold an ID and then parse for that ID of that JS value in the value that's in the map, and then you parse for the number stored and all of the above, and then you can store all of that in the button. So you would create each button as you iterate through the map.
Okay.
Okay, so I was trying to find my Python project from 115 because that helps with this. Did you take 115 here? Okay, so basically when you create a server, which is what's going to end up happening with the web GUI, right? You're going to it's going to show the page somewhere. And since you don't have server hosting or a domain or anything, it's just you're gonna set it to go to this URL, which is localhost 8080, which is the server that's currently running on your computer.
The 8080 may change depending on which specific route you hold it at.
Correct.
It should. Most socket servers are going to be hosted at 8080.
Correct. Yeah. If you make the desktop GUI, you don't need to worry about it at all. Or if you make the overworld GUI, right? So it's only worrying about the web GUI, and it's to show it in your browser. You use localhost 8080 or whatever port number it is at the end.
So I'm going to be sending JSON packets to my web page, right?
So since your website is HTML, CSS, and JavaScript, in order to get that information from JavaScript over to the Scala, right, your Scala backend, you have to use JSON to go in between. So yes, you're going to use JSON strings to go in between.
Mm-hmm.
Yeah.
But do you have to like finish all the lab activities to finish like the final MMORPG game?
Yes. The way the not the lab activities, sorry, the project demos, yes.
Only the
The-
Lab activity 4.
Yes, I know, because the project demo thing is at the bottom of lab activity 4. No, okay, so you do not need to finish all of the lab activities to finish the MMO project. You need to finish all of the project demos to finish the project. The lab activities just really help. Like you're going to end up doing the lab activities in order to do the project, right? So do the lab activities? Yeah.
Are we going to need the physics engine for our lab demo?
No.
Any code that he requires of you, so like if he requires physics engine for something,
he
will give it to you
yeah.
because he is not going to rely on your grade based on you getting points for a homework assignment.
Yeah. Also, I'm 98% sure you don't need the physics engine. The way the game is structured, I don't think you need it. So.
I think he is using gravity, but I think he
No,
implements
because
the code.
it's not that kind of deal.
It's not.
Have you ever played Final Fantasy?
I thought he had throwing health potions and stuff, and he was keeping track of it 3D.
Oh, maybe. I didn't think so. Okay.
If physics is required,
He'll give you
the code.
Yeah.
Don't worry about it. Do not have sleepless nights because you didn't get a perfect score on physics, and so you're worried that your physics is going to drag down.
Also, if you guys have any more questions about Project Phase 2, right? The end of Lab 4 has a really intensive, 4 pages about Project Phase 2. Read all of it. Then if you still have questions, come to us.
Do not walk into lab on the day of demo 2 and go, I didn't read this, I didn't know that I needed to do this thing. Please, for the love of God, do not do that. Read the entirety of that demo requirements.
Also,
it's in there for a reason.
Your project is due at the beginning of lab. Not, I'm going to walk into lab and finish it up.
Yeah.
It's due at the beginning of lab.
If you try to demo at the beginning of lab and it doesn't work, it is at the discretion of the TAs on whether they want to offer you more time. They are not required to offer you more time. If your code is broke when you walk into lab demo and you try to demo it and you fail some tests or that type of thing, that is your fault. You should have tested it more. They are not required to give you another go-around. We have a lot of people in some labs. We have some labs that have almost 30 people in them and only 3 TAs. That is 10 people per TA over a 2-hour time. And if demos take a while, and then also grading those demos, we can't necessarily go through everyone twice. So if your TA gives you a second shot on the lab demo because it didn't work the first time around,
be thankful, please.
thank them, be super nice to them. If you're also nice to them before the lab demo and then something breaks and you've been nice to them for the past few labs and not annoyed with them, then maybe they'll remember, hey, that person has been really nice to me, I'll give them a second shot. Versus if you haven't been nice to your TAs and something breaks, they just may go, well, it breaks, I can't give you the points for here, tough luck. Because that's how we have it structured of essentially, your demo needs to be done at the start of your lab. So here's a recommendation. If you have a Tuesday or Wednesday lab,
Yes, we know there is a 3 or 4 day gap between the first lab and the last lab. Yeah, they technically get 3 days more, but if they get 3 days more, you should be starting 3 days earlier than they are.
Because you get the lab 3 days earlier. Theoretically. Also, come on, if you guys are starting this like weeks ahead and you actually need 3 days in advance, there's a different issue.
Yeah. The lab demo should not take 3 weeks long. So.
Any other questions while we're here? What's up?
Is this week's lab activity applies Clicker, or
This week's lab activity, it deals with Clicker, but it's not Clicker.
GUI for it.
so we're using no one?
You're not using, so his Clicker code, as to because the homework is actually building Clicker as well, he's not giving you the Clicker code because we're not going to give you the homework code right before the homework gets assigned.
So basically the lab activity is you're building the GUI for Clicker. The homework is you're building the WebSocket server. So the same thing that would give you the localhost, right? You're building the actual Scala server on your computer for Clicker. Okay.
When is the project demo 2 sheet going to be posted?
It is. It's at the
bottom of lab activity 4.
Mm-hmm.
It may be reposted again on the week that is lab demo 2, but the demo 2 requirements have already been posted at the bottom of lab activity 4.
Yeah, it's on the 3rd through 6th page. What's up? Can you speak louder? No. In order to get full credit on the Clicker homework, you only need to make the WebSocket server. You do not need to make the GUI.
The lab we're testing the GUI because we can't test the GUI in AutoGrader, and the homework is testing the stuff we can test in.
Basically, what should end up happening is after this week in lab, you should have a GUI, right, that gets tested with Jesse's WebSocket server. And then after you finish Clicker, you should have a WebSocket server of your own, so you can use your GUI that you made in lab and your socket server that you made as homework, as like your homework project, and together you have made a Clicker game.
And then you can look at that entire Clicker game and go, okay, these are how I have these action event handlers set up. These are how I have this GUI set up. This is how I have this WebSocket server set up. This is how I have this and this set up. And what you can do is you can look at all of that and figure out, okay, with all of this set up, how do I use this so that I can use it on my actual demo? And by working with those together, you can figure it out on what you need to do for